Hello there, children. My name is Schmeichel Phelps, and I'm here to talk to you about some ratios and proportions. And I know what you're thinking. This is real bronze.
First thing we're going to talk about is a ratio. That's a comparison of two quantities using division. So down here you can see four examples of ratios. Here we have A over B, or A divided by B, or A to B. You could say that any of those three ways. Here we have 3 to 4. Here we have 50 miles divided by 1 hour. 50 miles to 1 hour. 50 miles per hour. Here we have $20 per pound. Each of these represents a ratio. Next thing we're going to talk about is an extended ratio. That's a ratio that compares three or more quantities. So here you can see two examples. We have A to B to C, or we have 3 to 4 to 5 if we want to plug in numbers for these variables. Now how this works, in an extended ratio, you have three quantities that you are comparing, and you're actually combining three separate ratios into one extended ratio. So the ratio of the first two quantities would be A to B. The ratio of the last two quantities would be B to C, and the ratio of the first and last quantities would be A to C. So it's all three of those ratios combined into one extended ratio. Now, a unit rate would be a rate or a ratio with a denominator of 1. So earlier we gave you some examples of ratios. Now, the only difference between a ratio and a unit rate would be a unit rate is just a ratio where the quantity in the denominator is just 1. So here we have 2 yards per every 1 second, or 2 yards per second. 43 feet per every 1 minute, or 43 feet per minute. 50 miles per every 1 hour, or 50 miles per hour. $20 per every 1 pound, or $20 per pound. These are unit rates because the quantity in the denominator is 1. Now, a proportion is a statement that two ratios are equal. So here we have two separate ratios, A to B and C to D. If we know that those are equal to one another, then we have created a proportion, two ratios that are equal to one another. An extended proportion would just be setting three or more ratios equal to one another. So we have A to B, C to D, and E to F. If we know that each of those ratios are equal to one another, we can set up an equation that looks like this, and we have created an extended proportion. Next, we're going to talk about the cross-product property. That's just a method for solving problems involving proportions. So the cross-product property, what's going to happen is you're going to be given a proportion. Here we have A over B is equal to C over D, or A to B is equal to C to D. If we needed to solve this or rewrite this so it wasn't a ratio equal to another ratio, what we would do is we would use the cross-product property. And what that entails is multiplying across and setting those two products equal to each other. So I'm going to multiply A times D and set that product equal to B times C. That's what the cross-product property allows you to do. Multiply across and set those two products equal to each other. Next, we're going to talk about a scale drawing. That's the use of a ratio to compare each length in the drawing to the actual length. This is how maps work. We have a map, and we are given two separate ratios over here. We're given that 1 inch is equal to 250 miles, and 1 centimeter is equal to 160 kilometers. That's for our unit of measurement in the US, and then the unit of measurement that everybody else uses, the metric system, which is way better. Now, the only reason that maps work is because of ratios like these. We are given a map and we can measure 1 inch, and we know that 1 inch is going to equal 250 miles. So maps wouldn't exist without ratios, so we need these. Now, there are 6 properties of proportions that I want to show you right now. If we are given the proportion that we were using earlier, A over B is equal to C over D, or A to B is equal to C to D. What we can do is rearrange them, and we would get ratios that would still be equivalent to one another, that would still equal one another. And how could you rearrange them so that they would still be equal to one another? Well, let me show you. If we know that A over B is equal to C over D, we know that B over A has to equal D over C. The reciprocals of each side have to equal one another. If we know that A over B is equal to C over D, we know that A over C is equal to B over D. If I were to swap the B and the C, and that makes sense, right? Because even if I were to swap these two and I get A over C is equal to B over D, the cross products will still be the same. A times D will still be equal to B times C. For the third property down here, what I'm doing is just taking the reciprocal of this one. Since we know that these two ratios are equal to one another in this proportion, then we know that the reciprocals of each side must also be equal to one another. For the fourth property over here, we know that this is just the cross product property. A times D has to equal B times C. Over here, this would just be the symmetric property of our cross product property. Instead of having A times D is equal to B times C, we have B times C is equal to A times D. For the sixth property down here, this looks a little confusing. We have A plus B over B is equal to C plus D over D. Interesting. How in the world would this be equivalent to this up here? Well, what actually happens is I'm going to add 1 to each side of this equation, meaning I'm going to add 1 over here and I'm going to add 1 over here. Now, instead of adding 1, what I'm going to do is add B over B. Instead of adding 1 over here, I'm going to add D over D because each of those are equivalent to 1. And when I do that, this is what comes out. I get A plus B over B is equal to C plus D over D. Now, if you ever want to know if another proportion is equivalent to your given proportion, just check to see if they have the same cross product. If I use the cross product property here, I would get A times D is equal to B times C. If I use the cross product property here, A times D is equal to B times C. A times D is equal to B times C. A times D is equal to B times C. Look at that. Each of these cross products are the same, meaning that we know that each of these proportions must be equivalent to our given proportion. And for this last one here, the cross product is actually the same if you were to simplify. If I multiply the quantity A plus B times D, I would distribute the D to the A and to the B. So I would get A times D plus B times D. If I were to multiply B times the quantity C plus D, I would distribute the B to the C and to the D. So I would end up getting B times C plus B times D. So each side of the equation then would have a B times D that I could subtract out, and I would get A times D is equal to B times C. So again, we get the exact same cross product we got with our original proportion.
Listen to your friend, Schmeichel Phelps, and just know that when it's example time, it's time to get in the pool.
Now, example 1 says if x over y is equal to 5 over 6, complete each statement. So here we are given 4 separate statements that we have to complete. And in order to complete them, we have to use the properties of proportions. So for this first one, we have 6 times x is equal to what? So we look up here, how did we get 6 times x? Well, we multiplied across 6 times x. So this is testing your knowledge of the cross product property. 6 times x has to equal what? Well, it's going to be y times 5, or 5 times y, or 5y. Over here, x over 5 is equal to what? Well, we look back at our original proportion. How did we get x over 5? They did the numerator over the numerator, so that has to equal the denominator over the denominator, y over 6. Down here, we have y over x is equal to what? So y over x would be the reciprocal of this ratio, meaning we have to set that equal to the reciprocal of this ratio, 6 over 5. Lastly, we have x plus y over y is equal to what? So that was the numerator plus the denominator over the denominator has to equal the numerator plus the denominator over the denominator. So 5 plus 6 over 6, or 11 over 6. Remember, you can always use the cross product property to check your answer. If I multiply across, I should get the exact same thing for each of these as I get with my original proportion.
You know what Schmeichel Phelps says, when you're winning, it's hard to lose. You try.
Okay, doing the same thing here. We're given our original proportion and we're testing our knowledge of the properties of proportions. So we start. A times B has to equal what? Well, again, this is testing your knowledge of the cross product property. A times B has to equal 100 times 60, or 6,000. Over here, A over 60 is equal to what? So A over 60 would be numerator over numerator. That has to equal denominator over denominator, 100 over B. Part C, we have B over 60 is equal to what? B over 60, well, that's just the reciprocal of this ratio, so that has to equal the reciprocal of this ratio, 100 over A. Lastly, we have 60 plus B over B equals what? So 60 plus B over B would be numerator plus denominator over denominator, has to equal numerator plus denominator over denominator, A plus 100 over 100. Don't forget, you can always check your answer using the cross product property. You should get the exact same cross product that you get with your original proportion. Now example 2 says solve each proportion. So we have x over 12 is equal to 5 over 6. To solve a proportion, we're going to use the cross product property. Now the way that works is we're just going to multiply across and set those two products equal to each other. So we go x times 6 is going to equal 12 times 5, or 6x is equal to 60. Now all we have to do is just solve this like a normal equation. We just divide both sides by 6 and we get x is equal to 10. Part B, doing the same thing. We again have a proportion where we have a ratio equal to another ratio, and we're solving for y. So in order to do this, we're going to use the cross product property. We're going to multiply across and set those two products equal to each other. Now, one of the biggest mistakes that people make on questions like these is that this y plus 3 right here, you're multiplying that whole quantity by 4. So it's going to be 4 times the quantity y plus 3. So make sure you put that in parentheses. Then our other cross product is going to be 8 times y. Now, the reason we have to put that in parentheses because you have to know you're going to distribute the 4 to the y and to the 3. So when you distribute that 4, you get 4y plus 12 is equal to 8y. Now we can solve for y. So how do we solve this for y? Well, we subtract 4y from both sides, divide both sides by 4, and we get y is equal to 3. Part C, doing the same thing, except this time it looks a little bit different. We have a to z is equal to 2 to 15. Now, this means the same thing as this over here. It's just written a little bit differently. So what we're going to do is we're going to rewrite it so it looks like one of these proportions. It's going to be 8 over z is equal to 2 over 15. Now we see that in order to solve this, all we have to do is use our cross product property. We're going to multiply 8 times 15 and set that equal to z times 2. So 8 times 15 is going to be equal to 120. Z times 2 is just 2z. Now to solve for z, all you have to do is divide both sides by 2. You get z is equal to 60, and you're done.
Tough for you to say.
Okay, doing the same thing here. The only difference is that this time we are rounding to the nearest thousandth when necessary. Here we have a proportion and we have a variable. So to solve for this variable, we're going to use the cross product property. That just means we multiply across and set those two products equal to each other. So here we're going to multiply 20 times 50, set that equal to 26 times f. So 20 times 50 is 1,000, and we're going to set that equal to 26 times f, which is just 26f. Now to solve this for f, we just divide both sides by 26, and we get f is approximately equal to 38.46. Again, we're rounding to the nearest thousandth. That would be 3 decimal places. Here, we're going to use the cross product property again to solve this proportion. So we start by taking 15, multiplying it to q, we get 15q. That's going to equal the quantity q minus 8 times 20. Again, since we have a binomial down here, you got to make sure that you put parentheses around this and multiply it to the 20. That way you know you have to distribute this 20 to the q and to the negative 8. So when we distribute that, 20 times q is 20q, 20 times negative 8 is negative 160. Now to solve this for q, we subtract 20q on both sides, we get negative 5q is equal to negative 160. Divide both sides by negative 5, we get q is equal to 32. For part C, we again have a ratio written a little bit differently. It's 19 to 21 is equal to m to 49. To solve this, what we want to do is rewrite it like one of these proportions over here. We're going to go 19 over 21 is equal to m over 49. Now we realize all we have to do to solve this is just use the cross product property. So we're going to multiply across and set those two products equal to each other. So 19 times 49, we're going to set equal to 21 times m. Now to solve this, all we have to do is divide both sides by 21, and we get m is approximately equal to 44.333. Again, we're rounding to the nearest thousandth, which would be 3 decimal places. Now example 3 says find the ratio of the longer side to the shorter side. So here we have a rectangle where our longer side is 60 inches and our shorter side is 40 inches. So we are finding the ratio of the longer side to the shorter side. So all we're doing is setting up a ratio. This is pretty easy. Now you can set up a ratio one of two ways. You can either do it as a fraction where it's going to be 60 inches over 40 inches and then simplify it, or you can do 60 inches to 40 inches like this and then simplify it. So how do we simplify this? Each of these is divisible by 20, so I can just divide both sides by 20 and I get 3 inches to 2 inches. That would be the ratio of the longer side to the shorter side. Part B, doing the same thing. Here we again have a rectangle and we're doing the ratio of the longer side to the shorter side. Again, since we're finding a ratio, you could either do it as a fraction where it's going to be 1,984 feet over 652 feet and simplify it that way, or you could set it up like this where it's just going to be 1,984 feet to 652 feet. Now, we need to simplify this. How do we simplify it? We need to divide each of these by 4. If we divide each of those by 4, we get our ratio of our longer side to our shorter side as 496 feet to 163 feet.
Time to go for the bronze. You try.
Okay, doing the same thing here, except this time we have triangles and we're finding the ratio of the base to the height. Again, since we're finding a ratio, you can do it as a fraction, where it's going to be the base over the height, or you can set it up like we have been doing. The base is going to be 22 yards to the height, which is 30 yards. We then simplify this by dividing each of those by 2, and we get our ratio of our base to our height as 11 yards to 15 yards. Over here, again, we're setting up the ratio of the base to the height. So it's going to be 242 meters to 121 meters. We can then simplify this, divide divide each of these by 121. If we do that, we end up getting our ratio of our base to our height as 2 meters to 1 meter. Now, example 4, it says the ratio of the measures of three sides of a triangle is 3 to 7 to 5. If its perimeter is 156.8 meters, find the measure of each side. Round answers to the nearest hundredth if necessary. So the way this works is that we saw when you create a ratio for given side lengths, you have to simplify it, meaning you divide each of these side lengths by a given number that they're both divisible by. Here, we have an extended ratio of our side lengths as 3 to 7 to 5. What that means is that if we took each of the side lengths of this triangle and put them in an extended ratio and simplified them by dividing each of those numbers by the same number, we would get a ratio of 3 to 7 to 5. So we need to figure out what is that number that divided into each of these side lengths to give us 3 to 7 to 5. If we find that number, then we can just multiply that number to each of these numbers and get the exact side lengths of our triangle. So how do we do this? Well, we're going to multiply each part of the extended ratio here by x. So instead of 3 to 7 to 5, it's going to be 3x to 7x to 5x. Now again, our triangle over here had three different side lengths that we put in an extended ratio and simplified and ended up getting 3 to 7 to 5. Now when you simplify an extended ratio, you divide each of them by the same number, which in this case we're calling x. So if x is that same number we divided each of the side lengths by, if we multiply 3 times x, we should get this exact side length. If we multiply 7 times x, we should get this exact side length. If we multiply 5 times x, we should get this exact side length. Now, how do we solve for x? Well, in the question, it gives us that the perimeter of this triangle is 156.8 meters. So all I have to do is add up each of these side lengths and set it equal to 156.8. So let's solve for x. Here I combine like terms. 3x plus 7x plus 5x is 15x. Divide both sides by 15. I get x is equal to 156.8 over 15. Now we don't like decimals in fractions, so to get rid of this decimal, we just multiply the numerator and denominator by 10, and then we can simplify this and get x is equal to 784 over 75. Now, we leave it like this. We don't round too early, because if we round too early and then try to figure out the side lengths, our answers will be off. Leave your x as exact as possible and don't round till the very end. So now we want to figure out our side lengths. To determine our side lengths, all we have to do is take this x and substitute it in for each of these side lengths. So our shortest side length over here would be 3 times x, or 3 times 784 over 75, which becomes approximately 31.36 meters. Our longest side length would be 7 times x, or 7 times 784 over 75, which is approximately 73.17 meters. And our last side length would be 5 times x, or 5 times 784 over 75, which is approximately 52.27 meters. Again, we're rounding to the nearest hundredth, which is 2 decimal places.
Schmeichel Phelps says it's okay to be mediocre. You try.
So this time, it says the ratio of the measures of three sides of a triangle is 1/4 to 1/3 to 1/6. If its perimeter is 31.5 centimeters, find the length of the shortest side. Round your answers to the nearest tenth if necessary. So we start by multiplying each part of the extended ratio by x. When we do that, we have created the exact side lengths over here. So this side length is going to be 1/4 times x. This side length over here is going to be 1/3 times x. This side length over here is going to be 1/6 times x. Now what we can do is solve for x by adding up each of these side lengths and setting it equal to 31.5 centimeters. Now to solve this, all we have to do is combine like terms. 1/4 x plus 1/3 x plus 1/6 x. We need each of these to have a common denominator, so we multiply this one by 3 over 3, multiply this one by 4 over 4, and this fraction by 2 over 2. Now they all have a common denominator, so we can add them together. 3/12 x plus 4/12 x plus 2/12 x is going to be 9/12 x after I combine the numerators. I can then simplify that. 9/12. If I divide each of those by 3, I end up getting 3/4 x. Now, what I can do is solve for x by multiplying both sides of this equation by the reciprocal of 3/4 to cancel it out. So if I multiply by the reciprocal of 3/4, that's 4/3. Over here, the 4's and the 3's cancel each other out. That's why we did it. We're just left with x. On this side, we take 31.5, multiply by 4, divide that by 3, and you end up getting x is equal to 42. Now we're going to take this and plug it in for x in each of these side lengths to figure out the exact side length. So we start with 1/4 x. If I take 42, plug it in here, multiply 1/4 times 42, I get that this side length of our triangle is 10.5 centimeters. I then go to 1/3 x, plug in 42 for x, simplify, I end up getting that this side length of our triangle is 14 centimeters. I then go to our last side length, 1/6 times x, plug in 42 for x, simplify, I end up getting 7 centimeters. Now we need to answer the question. It says if its perimeter is 31.5 centimeters, find the length of the shortest side. So which of these would be our shortest side? That would be 7 centimeters here, and you're done. Now example 5 says the ratio of the measures of 3 angles of a triangle is 7 to 5 to 8. Find the measure of each angle. So again, we are given an extended ratio. And what that did is it took the 3 angle measures and put it in an extended ratio like this, but simplified it. It divided each of the angle measures by the same number, and we ended up getting 7 to 5 to 8. So we need to figure out what number did we divide by, and then if we can figure out that number, we just multiply it to each of these parts of the extended ratio, and we can get the exact measures of each angle. So the way this works is we're going to take our extended ratio and multiply each part of it by x. We do that because x is going to represent that number that was divided out of each of these angles and left us with 7 to 5 to 8. Meaning that if we took that x value and multiplied it to 7, that would give us this exact angle measure. If we took that x value, multiplied it to 5, it would give us this exact angle measure. If we took that x value, multiplied it to 8, it would give us this exact angle measure. So now we need to set up an equation to solve for x. Oh, they don't give us a perimeter this time. That's okay. We know that the angles of a triangle have to add up to 180 degrees by the triangle angle sum theorem. So we create an equation where we add each of these up, set it equal to 180, and we can solve for x. So let's combine like terms. 7x plus 5x plus 8x is going to be 20x. We then divide both sides by 20. We get x is equal to 9. Now all we have to do to find the measure of each angle is take that 9, plug it in for x in the measure of each angle. We'll start with this one down here. We take 9, plug it in for x. 7 times 9 gives you 63. Therefore, this angle is 63 degrees. We go on to our next angle, 5x. We take 9, plug it in for x. We simplify. We get that this angle measure is 45 degrees. Lastly, we take that 9, plug it in for x over here. We simplify, and we end up getting that this angle measure has to be 72 degrees. And you're done.
Please don't fail on this. You try like I did in my swimming career.
Okay, doing the same thing, except this time the extended ratio of our angle measures is 2 to 3 to 8, meaning that we had an extended ratio of each of our angle measures. We divided those angle measures by a certain number and got 2 to 3 to 8. So the way we solve this is we let x represent that number that was divided into each of these angle measures, and leaving us with our extended ratio 2 to 3 to 8. So we multiply each part of this extended ratio by x. That will give us the exact values of our given angle measures. So we're going to let this angle represent 2x. We're going to let this angle represent 3x. We're going to let this angle represent 8x. Now, we create an equation to solve for x. We don't use the perimeter. We use the triangle angle sum theorem, which tells us that the sum of the interior angle measures of any triangle has to equal 180 degrees. So we add up each of these angle measures, set it equal to 180, and now we can solve for x. So we combine like terms. 2x plus 3x plus 8x is going to give us 13x. We divide both sides by 13. We get x is equal to 180 over 13. Again, we don't round too early. If you round too early, your angle measures will be off. We leave it as exact as possible until the very end. That's when we round. So now we want to find the measure of each angle. So we start with 2x. We take this x value that we found, 180 over 13, plug it in for x, simplify, and we get that this angle measure is approximately 27.69 degrees. Again, we're rounding to the nearest hundredth, which would be 2 decimal places. We go into our next angle, which would be 3x. We plug in 180 over 13 for x. We simplify. We end up getting approximately 41.54 degrees. Lastly, we do the same thing for our biggest angle measure, 8 times x. We take 180 over 13, multiply by 8. We get that the measure of this angle right here is 110.77 degrees. And you're done. Now, a word problem says, according to a recent study, 7 out of every 500 teenagers still say the word "bay" regularly. In a group of 350 teenagers, about how many would you expect to still say "bay" regularly? So first step in a word problem is to define your variables. What are you trying to find here? Well, we're trying to find in a group of 350 teenagers about how many would you still expect to say "bay" regularly. Well, we could say that x is going to represent the number of teenagers out of 350 who would still say "bay" regularly. So then we take that variable, variable and we write our equation. What's our equation? Well, again, we're trying to find the number of teenagers out of 350 who still say bay regularly. So it's going to be x over 350. That's going to be our ratio of teenagers who still say bay regularly. Well, aren't we given another ratio that tells us how many teenagers out of 500 still say bay regularly? Yeah, 7 out of every 500. So 7 over 500 is our known ratio. Well, if we know that ratio to be true, we can just take that ratio and set it equal to the ratio that we don't know, x over 350. Now we can solve this for x. How do we solve a proportion? Well, you use the cross product property. We multiply across and set those products equal to each other. So 7 times 350 is going to equal 500 times x. What's 7 times 350? That's 2,450. What's 500 times x? That's 500x. We then solve by dividing both sides by 500. We get x is equal to 4.9. Now, what were we trying to find? We're trying to find how many teenagers out of 350 still say bay regularly. Well, 4.9, you can't have 9/10 of a teenager. So we're going to say about 5 out of every 350 teenagers still say bay regularly. We just rounded up to the nearest whole person.